This is screencast number 3 for Module 4, Lesson 1. And we have looked at generating sequences using the explicit rule. Now we are going to look at generating sequences using a recursive rule. A recursive rule for a sequence defines the nth term by relating it to one or more previous terms. Okay? The following is an example of a recursive rule. If the first term is 4, then the nth term is going to be whatever the previous value of the function is. So previous value would be like now minus 1, or the value you want minus 1 plus 10. The rule means that after the first term of the sequence, every term is the sum of the previous term and 10. Okay, so it's probably just best to look at what exactly they mean in detail. Okay, so the first term is 4. So the first term of the function is 4. So that tells you that the first term is 4. Okay, and then they gave you a rule to follow that is a recursive rule. The next, or the term that you want, is going to be the previous term plus 10. So if you wanted the second term, it's going to be the value of the first term plus 10. So if I wanted the second term, I would put in here 4, because it's the second term minus 1, so that would be the first term. The first term is 4, so 4 plus 10. Okay, so it may look a little confusing at first, but I think that when we walk this through, you'll start to understand how exactly this notation works. Okay, look at this example 2. It says write the first 4 terms of the sequence defined by the recursive rule. Okay, so it says, it tells you that the first term is 2, and that each successive term is going to be the previous term plus 3. Okay? So for the first 4 terms, the domain of the function is 1, 2, 3, and 4. Okay? They told you the function value of the first term. Okay? So you're going to take that first term value, it goes in here, the function value of the first term. That's what they mean here. They don't mean put a 1 in there and start multiplying or doing something with it. Okay? So the second value, or the second term, is going to be the first term plus 3. And the value of the first term was 2 from here. Okay? So the value of the second term is the first term value plus 3, and that's going to give you 5. And then you take that second term and you use it to generate the third term. The third term is the value of the previous term plus 3. So that's going to be 5 plus 3, which is 8. The value of the fourth term is going to be the previous term, the value of the previous term, plus 3. So that's going to be 8 plus 3, which is 11. Okay? So this function's value is the sum of the previous term and 3. Okay, here's another example. The value of the first term in this particular situation is 4. And it says that the function value is going to be derived from the previous term plus 5. First value is 4, so I put the value of the first term in there. Add 5 to get the value of the second term. Put the second term value in, plus 5 to get the value of the third term. Okay? Take the third term value, f of 3 is the third term. So you say the value of the third term plus the 5 gives you the value of the fourth term. So the first 4 terms are 4, 9, 14, and 19. Okay, number 8 says to describe how to find the 12th term of the sequence in example 2a. So let's go back to 2a. Okay, 2a was this situation right here. Okay. So we're going to go and here's what we're going to do. We're going to have to take the 11th term and add 3. We would have to sit there and generate all of the values until we get the 11th term. We don't have that because we just had the first 4 values. But this is what you would do. To find the value of the 12th term, you would use the value of the 11th term and add 3. Okay? Suppose you want to find the 40th term of a sequence. Would you rather use a recursive rule or an explicit rule? And it explains your and then explain your reasoning. To me, it depends on whether I know the 39th term or not. If I don't know the 39th term, then I think the explicit rule makes more sense, because if I don't know the previous term, I'm going to have to find it. An explicit rule is basically something written in that function notation. If I can figure out what that function notation or that explicit rule is going to be, then that makes a lot more sense to me.